Already I have mentioned to find the derivative of implicit form or function, we have to first differentiate both sides with respect to x, then we have to apply the rules, laws or derivatives of standard function learned earlier. Actually ddx of minus fx, that is equal to minus ddx of fx. Minus means minus 1 is multiplied, that is constant. Next I have taken 3 sums. I shall work out one by one. First of all, first you write down the given equation 4. Differentiating both sides. With respect to x, ddx e to the power xy minus 4xy, that is equal to ddx of 4, or ddx e to the power xy minus ddx 4xy is equal to ddx of, on the right side, ddx of 4, that means ddx of constant, that will be 0, or now ddx of e to the power xy, power is xy. To find the derivative, we have to apply chain rule. You can do that mentally as I am doing. Follow. First of all, you consider xy as u. Then you find du of e to the power u into du dx. Chain rule is applied. Now ddu of e to the power u means e to the power u e to the power xy into chain rule du dx, that means ddx of xy. Follow this step. You consider xy as u, then e to the power u. You differentiate with respect to u, you get e to the power u. See this. Then du dx product, or with that product dy dx minus ddx of 4xy. 4 is constant, therefore 4 is taken outside, into ddx of xy, that is equal to 0. Now I see this one is common. I take that. Therefore, ddx of this one form derivative of product function. That is why x dy dx plus y into ddx of x, that is equal to 0 by e to the power xy minus 4. That is equal to 0. Since e to the power xy never 4, therefore this step. After that, x dy dx is equal to minus y into 1. I have taken this part on the right. Therefore, dy dx is equal to minus y by x. This is the answer. I think learners or students who are doing first time are noticing the steps carefully. Then next sum, x square plus y square is equal to log of xy. Differentiating both sides with respect to x. We can skip both sides also. Just we can write differentiating with respect to x. Meaning is differentiating both sides with respect to x. Then d dx x square plus y square is equal to d dx log of xy, or d dx of x square plus d dx of y square is equal to, now we note log of xy, that means function of function form. That is why we have to take xy as a new variable, say u, that means log u. After taking log u, you have to differentiate with respect to u. Chain rule is applied. Chain rule is very important. You must practice ddu of log u into du dx. Or this is 2x, this is again d dx of y square, that is function of y, hence we have to apply here chain rule, that means d dy of y square, that is equal to 1 by xy into d dx of xy, xy means product function, therefore we have to apply that product law, x into dy dx plus y into derivative of x, or 2x, oh sorry, I missed one thing, dy dx, chain rule, d dy of y square into dy dx, therefore this is 2y into dy dx, that is equal to 1 by xy into x dy dx plus y. Now we have to take dy dx term on the left side, space, or I first take the product here, 1 by y dy dx plus 1 by x, two y dy dx minus 1 by y dy dx is equal to 1 by x minus 2x. Or 2y minus 1 by y dy dx is equal to x 1 minus 2x square, or 2y square minus 1 by y into dy dx is equal to 1 minus 2x square by x. Therefore, dy dx is equal to y into 1 minus 2x square divided by x into 2y square minus 1. Already I have mentioned, to find the derivative of implicit form or function, we have to first differentiate both sides with respect to x. Then we have to apply the rules, laws, or derivatives of standard function learned earlier. We have followed that to get dy dx. Next sum, x root over 1 plus y plus y into root over 1 plus x, that is equal to 0. You see, if we try to express y in terms of x or x in terms of y, apparently we can't do that. That is why this is implicit form. This is treated as implicit form. But to find the derivative, we have to express y in terms of x or x in terms of y. Already I have mentioned. For that, we have to remove first these square root symbols. You follow what I am doing. Or x root over 1 plus y plus, is equal to, I take that second expression on the right side. Now on both sides we find there are square root symbols. Therefore, to remove that, we square both sides first. Squaring or you can write squaring both sides. Just by writing squaring means squaring both sides. Or x square within brackets 1 plus y square within brackets 1 plus x, or x square, I take y square on the left side plus x square y minus xy square. All terms are taken on the left side. Actually, you have to keep in mind that if we arrange like this, then the left expression can be resolved into factors. Or this is x plus y into x minus y. Now from these two, xy is common factor. Here we see x minus y is the common factor finally. Or x minus y whole into x plus y plus xy equal to 0. Generally we treat, if there be two variables x and y, generally we take these values of these two variables are unequal. Keeping that in mind, we write next or x plus y plus xy is equal to 0. You mention here as x is not equal to y. This is very important thing while you are working out such type of sums. Keep it in mind and you mention. Now we have got this reduced form x plus y plus xy is equal to 0. From that we can express y in terms of x. Take these two terms and take y common factor, and I take it on the right side. Therefore y is equal to minus x by 1 plus x. Finally, we have expressed y in terms of x. Follow these steps. Very interesting sum. Now, y has been expressed in terms of x. Therefore, there is no difficulty of finding dy dx. Differentiating with respect to x. Left side will be dy dx. Now, right side is of the form u by v. First of all, I take minus outside. Actually, ddx of minus fx, that is equal to minus ddx of fx. Minus means minus 1 is multiplied, that is constant. Then this is of the form u by v. U by v form. Therefore, I always suggest students you write the denominator first, means v square form. Then at the numerator that will be v du dx minus u dv dx. Now we simplify. Derivative of x with respect to x is 1. Therefore, this becomes 1 plus x minus derivative of 1 plus x, that is equal to ddx of 1 plus ddx of x. Now ddx of 1 is 0 and ddx of x is 1. Therefore, finally it is x into 1. Now these x's are cancelled. Therefore, minus 1 by 1 plus x whole square. Therefore, dy dx is equal to minus of 1 by 1 plus x whole square. This is the required derivative. Therefore, I have discussed few sums on derivative of implicit function. Now, I move to discuss next rule of finding derivative. Actually, we have not discussed still how to find derivatives of different types of functions or different forms of functions. Next rule, rule number 4. To find the derivative of inverse trigonometric function. Inverse trigonometric function, I think you know inverse trigonometric function, those who are reading in class 12, though this matter is not included in class 11, just I give idea. Saying sin theta equal to x. Sin theta is equal to x. Now, the angle theta is expressed as inverse function of x and written as also there is another form arc sin x. This is used popularly, therefore we shall confine taking this symbol. Therefore theta equal to sin inverse x. These two are equivalent. If x equal to sin theta, then theta equal to sin inverse x. Now if I replace this x here, theta is equal to sin inverse of sin theta. Also, if I call this one as A, here putting theta equal to sin inverse x in A. Also, this theta can be replaced here, sin of sin inverse x. These are actually equivalent things. Now, for any trigonometric function, we can apply this idea. If cos theta equal to x, then theta equal to cos inverse x. Remember, sin theta, already you know that least value of sin theta is -1 and greatest value is 1. Therefore, -1 less than equal to x less than equal to 1. If tan theta equal to x, then theta equal to tan inverse x. Here value of x is x, least value of x is -1, greatest value is 1, but for tan this is the basic idea of inverse functions. Also, there are more results, more identities on inverse function. Now we discuss how to find the derivative of inverse trigonometric function. I have used t function, that is trigonometric function, short form. I start by taking an example. How to find the derivative of sine inverse x. First I take sine inverse x is equal to y. From that, applying this idea, therefore x is equal to sine y. Using the basic idea, we can express x in terms of y, that is the definition actually. Now, we differentiate this one with respect to y. Differentiating with respect to y. Left side will be dx dy, right side will be dy of sine y. That is equal to cos y. Dx dy equal to cos y. Therefore, dy dx is equal to 1 by cos y. Now, cos y is to be expressed in terms of x. Using this one, x equal to sine y, you see from this cos square y is equal to 1 minus sine square y, that is equal to 1 minus x square. Therefore, cos y is equal to square root of 1 minus x square. We are considering here the interval of x as minus 1 less than equal to x less than equal to 1, and here we have ignored the negative sign. Actually, positive acute angle sense we are applying, that is why therefore ddx of sine inverse x is equal to 1 by square root 1 minus x square. Now you note that at the denominator there is under square root symbol 1 minus x square, and denominator cannot be 0. Therefore, you note mod x less than 1. That means minus 1 less than x less than 1. Here, if we put x equal to 1, then the denominator will vanish. That means division by 0. That is why mod x less than 1. Now, following this idea, you can find yourself. I am writing down the results. ddx of cos inverse x, that will be minus 1 by root over 1 minus x square. I suggest students, learners, you deduce yourself these results. I am writing down or making this chart. Actually, we have to use these results in future. In both the cases, mod x is less than 1. Then ddx of tan inverse x, that is equal to 1 by number 4 ddx of cosec inverse x, that is equal to 1 by x root over x square minus 1 with negative sign ddx of sec inverse x, that is equal to 1 by x root over x square minus 1. Number 6 ddx of cot inverse x, that is equal to minus 1 by 1 plus x square. I repeat, students, learners, those who are just learning how to find derivatives, you must deduce yourself using this concept.